So we're given a joint PDF and we have to calculate the variance of the first variable. Now, to get the variance of the first variable, we first need the marginal density of first variable, which is T1. So to get the marginal density of any variable, the standard process, as we know, is to integrate out the other variable over its entire range from the joint PDF. So basically, to get f of T1, we just integrate out the T2 variable from the joint PDF. So this is the joint PDF, and T2 from here we can see it goes from T1 up to infinity. So that's why we integrate with respect to T2 from T1 to infinity. So T2 is the only variable now, everything else is a constant. So this exponential can be broken down into e power negative T1 over lambda minus e power T2 over lambda, and the e power negative T1 over lambda is a constant because T2 is the only variable of integration. So that comes out, 2 comes out, lambda squared comes out. Let's remember T2 right now is the only variable we have. And so here we have to integrate e power negative T2 over lambda, and we know that the integral of e power ax is e power ax divided by a. So in this case, a is negative 1 by lambda, because T2 is playing the role of x. So we copy all this constant, and then the integral would be e power negative T2 over lambda divided by negative 1 over lambda. And T2 goes from T1 to infinity. And when we substitute infinity, so here lambda squared, and this is negative 1 over lambda multiplied. So that gives you just a negative lambda. So we have negative lambda, and then the upper limit is infinity, and we have a negative sign here with the e power, so it becomes e power negative infinity. And then minus the lower limit, which means minus lambda, which is plus lambda, and the lower limit T2 is T1, so it becomes e power negative T1 over lambda. Lambda was already there because of this and this. So e power negative infinity is 0, so this term goes away, and then this lambda squared and this lambda here multiply to give a lambda in the denominator, and then we have this 2, and then we have e power negative T1 over lambda times e power negative T1 over lambda, so that's e power negative 2T1 over lambda. Exponents add up since they're being multiplied. And now if we write this as negative T1 by lambda by 2, and here also if we take this 2 underneath this lambda, we recognize that this is an exponential distribution with mean lambda by 2, because we know that the PDF of an exponential distribution is e to the negative x by m times 1 by m. So m in this case is lambda by 2. So this is exponential with mean lambda by 2. And the question was to find the variance of, so this is not ft1, t2, this is just ft1. So this is the marginal density of T1, and the question was to find the variance of T1. And so once we see that the marginal density of T1 is exponential with mean lambda by 2, we know that the variance of an exponential distribution is the square of its mean. So it would be the square of lambda by 2, which would be lambda squared by 4. And that was choice A.